All right, problem 10. We're now starting with problems that are trigonometric integration, and those have rules you see from the formula sheet. And this first one is sine to the fifth. Find the zoom here. And sine to the fifth has to be broken up as sine to the fourth times sine to the first, because you're going to keep the sine t dt as your du, and you're going to convert sine fourth into cosines. And then, of course, sine being the derivative of the cosine, with, though, you have to take the negative into consideration here. But first things first, sine to the fourth can be written as 1 minus cos squared squared sine of t. Now, I've always promised students and that you won't have to do anything more than squaring a binomial on an exam. There's no chance I would have something cubed or to the fourth or to put you through that much kind of grief and torture. Well, anyway, but squaring a binomial is not too difficult. Just FOIL it out, and you'll get 1 minus 2 cos squared t plus cosine to the fourth t. Now, several ways you can do this. I split these out into 3 pieces, but you could actually leave it as one integral. To do that, you would just, because you're u is going to be cosine, and then the derivative of that's negative sine, so we would have a negative to adjust for it. But let's see if I can kind of freehand this on the mouse here. It's not going to look very good, but it would be 1. So I put the negative there. Of course, the integral sign's there. 1 minus 2u squared plus u to the fourth du. And it's because they're all sharing the same du. So since they sharing the du, you can do it like that. Of course, you have to account for the negative. Well, anyway, I chose to distribute it, which is fine. And so you see the sine of t dt distributes through the parentheses. And of course, sine of dt times 1 would just be sine of t. Sine of d, so there's a negative 2 cosine squared sine of t plus cosine fourth t sine of t. I'm really surprised that I did it this way versus the other way that I do it. All right, now, so each one of those you are adjusting for a negative. So integrating sine of t is going to be negative cosine. And with u being cosine, du makes that negative sign, so that negative changes that negative to positive. So essentially, you're just integrating 2u squared, which 2u squared would be 2/3 u cubed. And then the antiderivative, same thing here. It's going to change from positive to negative because that du is going to be a negative. And we have negative, so it's going to be antiderivative u to the fourth, which is 1/5 u to the fifth, but it's a negative because of the derivative of cosine's negative sign. And then there you go. So the u is cosine, of course. So negative cosine t plus 2/3 cosine cubed t minus 1/5 cosine of fifth t plus c. Now down here, this problem obviously would have started out as sine to the fourth, number 11 here. Sine to the fourth of 2x. So to evaluate sine to the fourth, you have to split it up as sine squared times sine squared. And then we have to use this integrating identity for sine squared. which is right here. 1 minus cosine of 2x. So it always doubles whatever angle is there. So if your angle is 2x, it'll be 4x when you double it. So you have 1 minus cos 4x over 2 times 1 minus cos of 4x over 2. The bottom denominator 2's can both come out, become 1/4 on the outside. And then you FOIL out 1 minus cos of 4x and 1 minus cos of 4x, which yields this result. Now what I did here, okay, the cosine of squared 4x, you have to use the identity, well, actually use one for cosine, but you use this version of the identity right here. So it's 1 plus cosine of 2x over 2. So you double the angle, so that makes it 8x. So if we go from 4x to 8x over 2. Now what I decided to get a common denominator here, and I said this was not the only way you have to do this step. I like doing this because I already know that I'm over 2 here, so I just kind of took this 2 cos of 4x and made it 4 cos of 4 over 2. And then 1, I made 2 over 2. So you see now they all share a denominator of 2, which I can take that denominator of 2 out and make that 8 on the outside. And then the 3 comes from that you would have a 2 here plus the 1 right there. Together that makes 3. That's just the way I like to do this, just to kind of keep the fractions all contained to the outside. So now we have a nice concise little result here to integrate. And that's pretty easy from this point forward. Antiderivative of 3 will be 3x. Antiderivative of 4 cos 4x will be sine of 4x. And then the antiderivative of cos of 8x will be 1/8 sine of 8x. Now one thing I'll mention here in the middle is that the antiderivative of cos of 4x is actually 1/4 cos of 4x, but the 4 in front kills the 1/4, so therefore there's no coefficient right there. And there we go. Now, I guess on a multiple choice answer, you might see the 1/8 distributed all the way through there. But on a handwritten answer, it wouldn't matter whether you did or you didn't. I wouldn't care. But to match the right answer, it's possible you would have to, I'd say more likely that you'd have to distribute the 1/8 through the parentheses, but that's not exactly advanced mathematics. So the next one, we have cosine cubed x sine negative 1/2 x dx. So whenever cosine is odd and positive, from right in here, number 2 in these rules, we save a cosine here for our du, and then we convert to sine. So when we take away a cosine from the cosine cubed, we have cosine squared. And then that leaves me a sine negative 1/2 x dx. So then you have cosine squared becomes 1 minus sine squared. We have a sine to the negative 1/2. And then you distribute this through the parentheses. Once again, you don't have to write it as 2 separate integrals, even though I did it that way. So whether you did or you didn't, it's okay either way. The sine of negative 1/2 times 1 would be sine of negative 1/2. And then sine of negative 1/2 times sine squared, you'd add the exponents. That gives you sine 3/2, property of exponents. And then you have u as sine of x, and then du would be cosine of x dx. But you don't have to adjust for negative or anything, because it's not, it's whenever u is cosine that you have a negative when you take the derivative. And u to the negative 1/2, u to the 3/2, both pretty simple power rules. N plus 1, n plus 1, pretty straightforward from there. You have this result, then you put your sine back in for your final answer. So it'd be 2 sine of x to the 1/2 minus 2/5 sine of x to the 5/2 plus c. Number 13. cosine squared x 3x. Let me bring up the original. So that's obviously has to be cosine cubed here. So there it is. Number 13 is cosine cubed. And so you take away one of the cosines and convert the other one to sine. Similar to the last problem. One important difference in this one, though. So the cos squared will be 1 minus sine squared. The important difference is with u being sine of 3x, you have to remember the chain rule. The derivative of that will be 3 cosine 3x. So that's something that's easy to forget to do and could cause problems. And so long as you remember that 3, so that means we have to adjust both of those by 1/3, which you see I've done right here, 1/3 and 1/3. Then once you do that, you're okay from here. So and then this is just cosine of 3x by itself, so the antiderivative will be 1/3. Sine of 3x. I guess for this one though, I probably shouldn't have put the 1/3 out there in front. Actually, well, because really it's 1/3 du, because you see that's when you pull out, that's du. So then it becomes 1/3 of u, and that's why it's the whole final result. Maybe I shouldn't have put the 1/3 there. That 1/3 should be, because after you, it might be confusing here, because it might look like it's going to be 1/9. So if I could handwrite that right now, I would fix it, but I can't. But this is correct. It would be 1/3 sine of 3x. This one's going to be basically u squared du with a 1/3 in front. And that makes it, the antiderivative u squared is 1/3 u cubed. So 1/3, and this one does produce a third here. So it makes it 1/9. And then it's u cubed, so therefore it'll be 1/9 sine cubed. So you have 1/3 sine of 3x minus 1/9 sine cubed 3x plus c. Now here we have a sec cubed and a tan cubed, both of x over 2. So you'll have a sort of a chain rule situation here when you integrate this. But that's going to be one of the explanations here. Tan is for the secant. Tangent's odd and positive. Sometimes more than one rule will apply, but I generally tend to not pick test questions where more than one rule applies. But I believe I have some in my examples where that's the case. So tangent's odd and positive, so you save a sec tan, and we'll convert to secants. So you see, I took away a secant, I took away a tangent, put it right here. It's going to be my du. And then I convert tan squared into sec squared minus 1, because I need everything to be secants. And so I take sec squared, and then you have all this du right here together. So basically it's sec squared times that du. So that's what makes this sec fourth, and there's the du. And then here's the du, and that way you have sec squared times 1, which just makes that sec squared. So we have u then equals secant of x over 2, so the chain rule is going to produce a 1/2 in your du here, which means to adjust for the 1/2, I'll need a 2 on the outside. Like I have for both these intervals, I have 2's on the outside. So then it boils down to that point, you're just integrating, since your u is a secant, you're integrating u to the 4th. And then over here, you're integrating u squared, and then the 2 takes care of the chain rule, but then that's your du right there. And then basic power rule, so antiderivative of u to the 4th will be 1/5 u to the 5th, so the 2 makes it 2/5. and u squared will be 1/3 u cubed, but the 2 makes it 2/3. So you end up with 2/5 secant fifth of x over 2 minus 2/3 secant cubed of x over 2 plus c. Number 15. We have tan squared divided by sec x. Now this one didn't necessarily follow one of the rules. I chose to do it this method, where I let tan squared be sec squared minus 1 and split it into two integrals, which then sec squared over secant becomes secant. And then 1 over secant is the same thing as cosine. So on the formula sheet you have the integral for secant, which is natural log of sec plus tan. But this one you need to know right here, the basic trig derivative integrals you need to know. And when I say basic, I mean ones that don't include natural log in the answer. So the antiderivative of cosine would be sine with a negative in front. So you had to, that one's a little tricky because it didn't really follow one of those patterns. I don't think sine and cosine is really a good idea here, converting sine and cosine. I don't think that's going to help that much. Okay, this one was a little strange, I think, so probably not one I'm likely to ask. One that has like tangents and secants that doesn't fit a pattern, I generally like for those to be convert to sine and cosine. All right, number 16, cosine fourth, tan fourth, cosecant of 3 theta. Yeah, now this one, tangents works, tangent pairs up with secants real well, but tangent and cosecant doesn't really go together very well. So that was kind of a clue to convert this to sines and cosines. Yeah, tangent secant's a different story. So you see what happens when you convert this to 1 over sine the fourth, and then tangents sine 4 over cos 4. You cancel the sine 4s. And then that's going to leave 1 over cosine to the fourth, which is secant to the fourth. And then for secant to the fourth, you save the, for even, secant, even, and positive. It's one of those rules. You save the sec squared, and you convert the other sec squared into 1 plus tan squared. So then we have, you distribute, so sec squared times 1 will just be sec squared. And then sec squared, so then you'll have tan squared sec squared here. Chain rule again, so if u is tan of 3 theta, du will be 3 sec squared theta d theta. So we have 1/3 to adjust it for the 1/3. Now that's for the one on the right here. This one, similar to earlier, that integral here, the first one, secant squared, would just be 1/3 du. So that which then makes it just 1/3 u. So you'll end up with 1/3 tan of 3 theta. So here you have 1/3 u squared, like I have written right there in the red, which would then be u cubed over 3. So it's going to be 1/9 tan cubed. So you have 1/9 tan cubed plus c. Number 17, definite integral. Unlikely to put a definite integral like this on test, but I'll go through it real quick since it's here. Sine squared, the only definite integral I would probably expect on this exam is for improper integrals. So I use the conversion formula for sine squared, 1 minus cos of 4 theta over 2. I pulled the 2 out, so it's 1 minus cos of 4 theta. The antiderivative of 1 will be theta. Antiderivative of sine of 4 theta, cos of 4 theta, would be 1/4 sine of 4 theta. And then we plug in the pi over 4. So we put it for theta, that's going to give you a pi over 4. 4 times pi over 4 is pi. Sine of pi will be 0. The bottom one, you put in pi over 8 for theta, makes it pi over 8. Put in pi over 8 for theta here. 4 times pi over 8 would be pi over 2. Sine of pi over 2 is 1, but you have the 1/4 in front, so that's for the 1/4 here. 1/4 times 1. And then, there's a 0. We don't need the 0. Watch out for the negatives. So you have a 1/2, and you end up with a pi, because pi over 4 minus pi over 8 is pi over 8. Pi over 8 plus 1/4. I just got a common denominator here. Makes it pi over 2 plus 8 times 1/2. So the exact answer would be pi plus 2 over 16. All right, number 18 uses this integrating identity right here. Sometimes, every once in a while, a student will make a mistake and think that this result that's on the formula sheet right here, that they think that's the result of the integral. That's not true. That's just how you convert the original problem into something that can be integrated. So, so sine 3 cos x cos 2x follows this formula right here, sine m cos n. So always has a 1/2. Every one of them is a 1/2 with that one. So basically you have m minus n. So you have 3x minus 2x makes 1x. And then you have plus sine of m plus n. So you have to be careful. There's 3 of these formulas for like sine, sine, cosine, cosine, and they're kind of close to each other. So just be careful that you don't look at the wrong one. So you have sine of 5x, because it'll be 3x plus 2x. And the sine of 5x, and then once you have it converted, it's easy from there. Antiderivative sine of x is negative cos x, and the antiderivative of sine of 5x would be negative 1/5 cos of 5x. And, you know, multiple choice answer most likely would probably have the 1/2 distributed through the parentheses, but I think that would be the least of your concerns at that point. So, takes care of the trig integration.